Hello, and welcome to this Patton webinar. I would like to review a few housekeeping items with you before we begin. Let's take a moment to help you familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Patton Presentation in the upper left is the primary window for today's webinar. You should be seeing the welcome slide there right now. Just to the right of the main presentation window is the speaker bio window with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the Q&A window and click Submit. Your question will be placed in the queue for the speaker to address when we get to the Q&A session. At the bottom of your screen, you see 10 buttons. The first three either minimize or restore the three windows we've already talked about. The others allow you to access resources, contact us, share this webinar with colleagues, take a survey to provide feedback to our presenter, and lastly, do a little troubleshooting like running the system test or consulting the frequently asked question document. The button second from the right is the volume control for the webinar, but it is probably best to leave that button alone and adjust your volume using the controls you are familiar with on your system. If you can't remember what a particular button does, just hover your mouse pointer over it and a tooltip will appear with a description of the button's function. And now let me introduce today's presenters. Burton A. Patton, EVP. As co-founder and board member, Burt plays an active role in key management decisions and is involved in strategic and business planning for the company. Burt has over 20 years of experience in the industry, and he holds a BS from the University of Maryland. Joining him is Nathan Meyer, Senior Product Line Manager with decades of experience in the networking field. Mr. Meyer specializes in product specification and design with experience in detailed networking protocol operations and systems troubleshooting. Nathan holds a BS from the University of Minnesota and an MS from Johns Hopkins University. Next is Johnny Grant III, Product Line Manager. Mr. Grant is responsible for identifying market requirements and defining product solutions that address true customer needs. And Sean Garrity, USA Sales. As the leader of Patton's North American sales operations, Mr. Garrity will discuss current opportunities to leverage relevant Patton products cost-effectively in the real world. So now let's get to the agenda. Burt will be speaking on who is Patton. John will then follow with Industrial Ethernet coming of age. Nathan will then touch on serial versus Ethernet, then back to Johnny for Ethernet limitations, case studies, and enabling connectivity. And Sean will do our closing. So now that we've met everyone and run through our agenda, here is our first presenter, Burt Patton. Burt?
Katie, thank you. I really appreciate that great introduction. I'm also really excited about this webinar today, and wow, what a great turnout. Thank you all for coming. The subject that we're going to be talking about today is a big subject in industrial communication, and that is the convergence of networks and the movement to really an all IP world. So my job is to present you Patton. I'm going to do it in a little bit of a different way. The main point that I want you to understand today about Patton is that the migration that we're talking about here in terms of technology is something that we've participated in for a long time. Basically, we've lived it, and we are living it, and we're going to probably be living it for a long time. Our story is one of ongoing technology development, innovation, and the migrations that are driven by those developments. Today, we're a medium-sized equipment vendor. We serve a variety of markets. We serve the telecom market, the networking business, security, and of course, industrial communications. But we've emerged over a long 28-year period, and we grew our business year over year by reinvesting our profits back into product development. I might be bragging just a little, but we are a family business. We're privately held, but family does not really mean mom and pop. I'm proud that we're not only an international company but a multinational company. We're doing business in 130 countries. We have 180 employees worldwide. Our worldwide headquarters is here in Gaithersburg, Maryland, but we have sales and support operations in basically every region in the world. Most of our product development is centered in Gaithersburg, Maryland, but we do have some development centers in other places. For example, for voice over IP technology, our competency center is in Bern, Switzerland, where we house a team of embedded software engineers, and that location also serves as our European headquarters. You know, Patton really started out though as a cottage industry, and we got to where we are, you know, one step at a time. And like, you know, other American stories, you know, we started in the basement of our house and with our own money, and really while we were just kids. And since we had to grow our business, like a lot of companies from our, you know, without any outside investment, we had to start small, and that's exactly what we did. You know, from this idea that I'm talking about as Patton moving up the technology food chain and living these migrations, you know, I'll give you kind of the little timeline on our product development. Our first product was a DB25 gender changer for RS-232. Then we made DB9 to DB25 adapters. From there, we moved into RS-232 short-range modems, you know, very much like the Ethernet extenders we're talking about today. Then we moved into RS-232, 422, 485, and current loop converters. That led us into the multiplexer business. Multiplexer business led us into wide area networking, and we developed CSU, DSUs. The CSU, DSU business brought us into T1 technologies and E1 technologies. That led us into routers. Router products led us into dial-up remote access technology that we originally developed for dial-up internet access, but it's used still today extensively to provide dial-in access to sensor networks and PLCs. Our experience in these transmission technologies then moved us from analog modems into DSL technology, which we leveraged for both telecom and industrial network applications. We invented the Ethernet extender by adapting these DSL technology that were originally for commercial and telecom use into industrial applications. We used the DSL transmission techniques. We made the units auto-connect, auto-configure, basically plug and play, and very user-friendly. And then we hardened them for the industrial networks and adapted the designs many times over for our customer applications. And by the way, all of these, you know, quote-unquote legacy products are still in our portfolio and still available, and we have lots of customers who appreciate that. You know, we keep up with technology developments, but we try to keep our portfolios around as long as possible. You know, some of these products that we're selling have been built and sold by us for decades. So if you're still in the market for things like converters and line drivers and device servers, you know, we're still proud to have these products around. You know, very often, you know, what we're about is helping companies leverage their past capital investments in technology and get the most out of those investments that they possibly can, while adopting the new technology in order to reduce operating costs and also to stay relevant in the market. So here's my point. All of those technologies that I just talked about and those products and the market segments that we're dealing with, they're all converging. It's why we're having discussions about everything from triple play services in our homes to smart home technology to the Internet of Things and smart grid technologies. You know, these things are not only changing our lives and the life for the next generation, it's in fact changing the way we connect and manage everything from weather monitoring to manufacturing. So another way to say it is that the phenomena that we're talking about today in the industrial market is not isolated to the industrial market. this drive for convergence towards an all-IP network in both the local area and the wide area is happening. And, it's been talked about for a long time, but it's really, really happening. And, in fact, it's happening so much that I think we've gone beyond the point of no return. Patton's living it, and we're going to continue to live it. I guess if there's one thing I want you to take away from my presentation about who we are, it's what we can do for you. Patton is small enough and close enough to our roots to really care about our customers. We're big enough to have some serious capabilities to serve our customers' needs. And because we're bringing products to market which are homegrown and made by us in the USA, we have the ability to address customer needs through adaptation and customization. And so in a nutshell, we make stuff, and we're aspiring to deliver you unrivaled service in this industry. So that's all for my comments today. I really appreciate you guys inviting me to say a few words, and now I'll turn the table back.
Okay, Bert, thank you so much for that part of your presentation. If you don't mind, I do have a couple questions that have come in, if you wouldn't mind answering them.
No problem.
Okay, the first one asks, if you guys have been around since 1984, why have I never heard of you?
That's a good question. Maybe I'll rephrase the question. I think that the participant is asking, where have you been all my life? No, I shouldn't compliment myself too much. And, listen, we've been spending a lot of time and money branding ourselves in telecom and networking. Even though we came from this from this serial connectivity business, we kind of haven't focused on it for the last few years. But with this new product launch that we have going on, we're really interested in branding ourselves in this space. We think that we have something important to offer the marketplace. And, frankly, one of the reasons why we're having the webinar is because we'd like to get the word out about us because, we don't like that question. We want everybody in the world to know who we are.
We do have one more question that's come in. This one asks, what's the size of your company in terms of employees and revenue?
Employees is easy. I mentioned that we have 180 employees worldwide. In terms of revenue, it's a little bit of a difficult question to answer. We are a micro multinational. We have trading entities all over the world, and some of them we consolidate financially on our own financial statements here in Gaithersburg. Others we keep as separate entities, and we don't consolidate financially because we don't have to. But if you just take the group and add up the top line revenue of each of the companies in the group, our revenue is approaching $100 million.
Bert, thank you so much for that presentation and answering a couple questions. We might get back to a few more questions at the very end here. But next, I'd like to introduce Johnny Grant. He'll be our next presenter. So, Johnny, go ahead.
Hey, great. Thanks, Katie. Thanks, Bert. As introduced, I am Johnny Grant, Product Line Manager for Patton's Connectivity Portfolio. I assume by all your all's attendance in this webinar that you are well aware that industrial comms, physical layer connectivity, RS-232, 422, 485, current loop, and the like, have been stock standard for decades. Well, the reason we're talking today, these standards of choices are changing. For reasons which Nathan and I will explain, Ethernet and IP is quickly becoming not only a new standard, it is becoming the standard. For industrial environments, Ethernet initially began at the management and control levels of a production plant. It's clear, however, Ethernet has crossed the chasm and is now penetrating down to the industrial device level. On the factory floor and the enterprise and security networks, Ethernet is to become the network that connects PLCs, sensors, and all kinds of other devices and automation together. In 2010, the market for Ethernet equipment was over $16 billion. This is an aggregate of total of all industries, not specific to the industrial market. Some facts that are geared directly to the industrial segment are almost 25% of the 31.3 million industrial network nodes today are Ethernet. Over 40% of those are using the common and widely used Ethernet variant, TCP/IP. That means that 75% of the nodes are still connected on legacy serial interface. The compound annual growth rate of installed Ethernet-based nodes is now forecasted to increase 13% from 2010 to 2015. Organizations such as Profibus International expect the number of Ethernet devices shipped for manufacturing applications alone to continue to grow at an average yearly rate of more than 35% over the next few years. Really, in a nutshell, we are seeing acceleration of the trend away from serial to Ethernet. This acceleration has a lot of reasons behind it. Ethernet is ubiquitous in its own right, has been universally adopted across all market segments, and its physical method of connecting everyone and everything to the Internet. The growth is now due to much more than the merits of Ethernet. You see, the electronic component suppliers, critical to the manufacturing of legacy serial devices, are putting components into EUL status. UARTs, interface chips, line drivers, op-amps, they're all going away. With these components becoming harder to find, manufacturers of industrial devices really have no choice. Coincidentally, this is one of my biggest challenges as a product line manager who has many such legacy devices under my management. We still offer those serial interface converters, modems, line drivers, muxes, and device server products, but every day, honestly, it becomes more and more of a challenge. There's little doubt the acceleration of Ethernet is now. Here's a quick peek at the industrial side of the equation. The market for industrial Ethernet components is now being measured by the analysts as an important market segment. This gives you an idea of the Ethernet equipment that is widely used for industrial Ethernet applications. It is remarkably similar to the enterprise and or telecom markets. Like Bert alluded to earlier, these are markets which Patton is addressing with a wide variety of solutions. All right, Katie, I'd like to hand it back to you.
All right, Johnny, thank you so much for that part of your presentation. I do have one question that popped up, if you'd like to answer it now.
Sure.
All right, the question asks, does the low percentage of converter sales mean that most of the non-Ethernet devices out there have already been either converted or replaced?
There's not a real simple answer to that question. Quite honestly, converters is a very, very wide, could be a wide variety of devices. In truth, we see really about a 50-50 of people looking to either convert their Ethernet to serial through our serial device servers. And we also see applications where the devices themselves, the endpoint devices, are no longer being supplied with the various different serial interfaces, only Ethernet interfaces. So in truth, I see about a 50-50 split between applications in which we do conversion versus applications that are just completely replaced with Ethernet.
Yeah, can I chime in?
Mm-hmm.
So it looks like from the statistics we're looking at that we still have 75% of the installed base that needs to be turned over from serial communications to Ethernet. So there's a wide market opportunity to turn it over. So that's data point number one. Data point number two is for maintenance of those networks, for getting new cards, new endpoint devices, or expansion of those networks. They're no longer available in serial communications. So it's forcing the industrial market into a conversion to Ethernet. And I think that's really the point.
Thank you so much for answering that question. I think we'll be coming back to you later, but next up we have Nathan Meyer. He's here to do our next part of the presentation. So Nathan, go right ahead.
Thank you very much, Katie. And thank you, Johnny. And thank you, everyone, for joining all of us in this webinar. I'm Nathan Meyer, product line manager, and I work with Johnny directly. I want to take an historical view from the 19th century onward at communication technologies that in most cases have evolved and remain with us today. Current loop, firstly, has its roots back in the mid-1800s in the telegraph industry. From that context, it's rather obvious that this technology works over long distances, depending upon the maximum current available from the source. I also find it fascinating that twisted pair wire goes back to those early times, because without it, it's impossible for the signals to traverse such a long distance. If you've ever visited a museum about the Old West, you may have noticed the dozens of types of barbed wire that far outnumber the different types of twisted pair communication wire we have today. But I don't want you to think that barbed wire is used for communication. It's simply used for containing cattle in a range, not the telegraph. In industrial applications, one of the notable key benefits is low susceptibility to electrical noise, or EMI. Also, the data rates are typically low, but the technology survives today. Perhaps the most common use of current loop is in the MIDI, M-I-D-I, the MIDI interface, well known to musical performers. RS-232. In the early 1960s, RS-232 made its name in the communication world for the DTE-DCE connection to dial-up and lease-line modems. Current loop RS-422 and RS-485 standards are electrical standards, but RS-232 is much more than an electrical specification. It defines this DTE-DCE interface, identifies the unbalanced data signals and control signals, and how they function. In other words, it's more intelligent because it defines the when and why various control signals turn on and off. In the industrial environment, RS-232 is used in two main applications. One, in the use of dial-up modems for making a temporary communication channel through the telephone company over longer distances. And two, in simpler scenarios needing the use of short-range modems or interface converters that operate over private dry copper lines. Due to the nature of these applications, the distance is short and operate with low data rates. Now, the original standard stated a maximum data rate of 20 kilobits per second, but your PC can configure its RS-232 serial port, if it has one, up to 128K bits per second. Many say that it operates up to 50 feet, but that is incomplete error. The standard states it must operate a minimum of 50 feet at the maximum data rate. Imagine for a moment that the standard said it operates up to 50 feet. In that case, the standard would be met if it operated only 2 inches. RS-422. Due to the speed and distance limitations of RS-232, RS-422 is commonly used to extend the range of RS-232 in the short-range modem application. Unlike RS-232, the RS-422 standard only defines the electrical parameters for a balanced circuit, so it uses twisted pair. The twisted pair offers immunity to electrical noise. It's a good fit in the industrial world's applications with a single master and multiple receivers. It can be used in point-to-point, multi-drop, or star technologies. If used in a multi-drop topology, it is commonly used for sending programs to PLCs. In star or point-to-point, bidirectional communication capability broadens the application. Let me list some of them. Process automation with chemicals, brewing, paper mills. Factory automation, such as autos and metal fabrication houses. HVAC, security, motor control, and motion control. The maximum data rate is 10 megabits per second. Now, the limitation is that RS-422 has only one driver or transmitter, but it supports up to 10 receivers with a twisted pair connection, also known as a 4-wire connection. 485. To overcome the limitations of RS-422, the Electronic Industries Alliance, EIA, introduced the RS-485. It can support from 32 to 256 devices, and it has a real master-slave electrical configuration. Half-duplex communication can occur between any two devices. How is this done? When a device is not transmitting, the transmitter is in a high impedance or off state, as if the transmitter were not connected to the circuit. During these times, the receiver is on and may receive a message from another device. Each device has a name or address. Only when the message bears its name will it take the appropriate action to the message. RS-485, now known as TIA-EIA 485, became immensely popular. It still is. Like RS-422, the standard defines only the electrical parameters. However, it led the way by being the physical infrastructure for using communication protocols in industrial applications. You'll probably all recognize one of the most popular, Modbus, which was designed for use in RS-485 networks. It can operate over 2-wire or 4-wire. Simplex, though rarely, half duplex, the most common, and full duplex in 4-wire mode only. The data rates can reach up to 35 megabits per second, and as with current loop and RS-422, the twisted pair offers immunity, high immunity to electrically noisy environments that may have motors, welding equipment, etc. All right. Summary of legacy interfaces. This slide displays the interface types we have just discussed, showing the common topology and applications. Topologies can be point-to-point, star, ring, which is the same as loop, and multi-point. All except the RS-232 application use private dry copper twisted pair. The dial-up modem, RS-232, uses the telco's circuits. One last point about the numbering and naming of these standards is that the RS-232, RS-422, and RS-485 standards are now called EIA 232, EIA 422, and EIA 485. Perhaps because I became familiar with them long ago using the RS prefix, I still refer to them as the RS standards. This slide sums up many of the parameters related to the interfaces we have been discussing. You'll note on the right it includes Ethernet to be discussed shortly. The table's columns are arranged approximately in an older to newer timeline order, that is, from right to left. Industrial applications are as varied as the world is biodiverse. Depending upon your industry, this application in the energy industry is one example. The energy industry, whether in oil, gas, wind turbine, or other energy field, needs to measure the flow of oil, the flow of gas, generated electricity, etc. Starting with number 3, this building represents the central location for communicating with flow computers located at the numerous derricks. From this central location, the operator can calibrate, program, configure, request a data dump, or do other necessary operations. The flow computers in the application diagram offer both RS-232 and RS-485 electrical interfaces, having a maximum data rate of 19.2 kilobits per second or 38.4 kilobits per second, respectively. The SCADA server, on the other hand, has only an RS-232 interface. So for a point-to-point connection, modems are connected at each end of the link, one at the flow computer, the other at the SCADA server. For a multi-point connection, a single RS-232 to RS-485 interface converter connects to the SCADA server with 2-wire twisted pair reaching the flow computers at each derrick. This is a major advantage in using the RS-485 connection, in that only one port on the SCADA server is needed. Furthermore, to communicate efficiently, the SCADA server uses the Modbus communication protocol. Protocols for the efficient use of serial connection. We've all shipped items that are delivered to friends, family, other organizations, or one of a million destinations around the world. If they were not packaged, it would be a mess. Items would become separated and not all arrive at the destination, if at all. They'd be broken, mixed with other items. Well, you get the idea. It's no different in data communication. Data needs to be packaged so that it's delivered to the right destination, so that it is not lost, simply so it gets done properly and efficiently. Numerous synonyms used in data communications for packaging. You may have heard of encapsulation, or frames, or perhaps some others. The Modbus serial communication protocol was published by Modicon in 1979 for use with PLCs. It became a de facto standard, was openly published, and offered royalty-free. The framing or encapsulation is simple. The start and end markers delineate the message. The destination address will be identified by the proper receiver, and upon reading the message, the receiver knows what to do, that is the function, what to do with the data relevant to that action. To prevent doing an incorrect action, a cyclic redundancy check, or CRC, is appended to the frame so the receiving device can detect corrupted messages. Now, in contrast to Modbus, let's look at the example of Profibus, another very popular industrial communication protocol. A German company first promoted it in 1989 and subsequently was used by Siemens. It was designed principally for use in automation technology. This is a common theme when looking at the various industrial communication protocols. That is, designing a more efficient protocol for specific industrial purposes, such as real-time control, or even more specifically, real-time motion control. Consequently, Profibus was designed for a slightly different industrial market application than was Modbus. It, like Modbus, originally was intended for use over RS-485. It's used on a multi-drop or bus topology using data rates from 9.6 kilobits per second up to 12 megabits per second. But unlike Modbus, Profibus is not openly published and is not royalty-free. Do you remember the album by George Jones called And Along Came Jones? One of the songs on the album is You Done Me Wrong. Well, I just want to say now, and along came Ethernet. So will Ethernet do us wrong in the industrial arena? Ethernet has proven to be the most adaptable technology, perhaps bar none. So it's important to be sure that Ethernet does not do us wrong. The challenge was putting the industrial serial communication protocols with Ethernet, and it was done in two ways. Modbus was placed in the OSI application layer and runs over a standard Ethernet network, the same type of Ethernet network used in homes and offices. Profinet, already being proprietary, morphed Ethernet into even more proprietary. Don't misunderstand me. They did not do this maliciously. They were intensely concerned with real-time applications. But Ethernet is non-deterministic. That is a major issue. Therefore, modified standard Ethernet is for desired real-time control. One other point, for connections from a non-standard Ethernet to standard Ethernet network, a gateway is required. However, notice that under the standard Ethernet protocol stack, CIP motion, which is a real-time protocol, does operate over standard non-deterministic Ethernet. To sum this slide, some of the protocols are Ethernet friendly and others are variants using Ethernet's physical layer, modifying higher layers to meet specific application requirements. Here is a table that compares the various industrial communication protocols. I'll put everyone to sleep and go far over our time limit if I were to discuss these. So you certainly may browse this table when you request your copy of this presentation. Quickly, let's look at projected growth from 2011 to 2015 of the new industrial Ethernet nodes with respect to the use of these Ethernet industrial protocols. Some Ethernet-friendly protocols will increase in percentage of market, such as Ethernet IP. Note, though, that the IP in Ethernet IP is for industrial protocol, not Internet protocol. On the other hand, some Ethernet variant protocols also are increasing in percentage of market, such as EtherCAT. Now, EtherCAT is Ethernet for Control Automation Technology and is an open, high-performance Ethernet-based field bus system. The development goal of EtherCAT was to apply Ethernet to automation applications which require rapid update times with low communication jitter and low hardware costs. So how do we square away this projection with the tendency toward the more open, the standard Ethernet usage? There are many reasons behind that. Some are business competition. Another is specific requirements in industrial networks. But remember, Ethernet is the protocol of the past, the present, and the future. Let's look at the modified gas and oil application scenario in the migration from legacy to Ethernet. The two incremental scenarios show the cost-effective and technically easy way of migration. It can be incremental step number one. Consider wanting to use your flow computer with an RS-232 interface that's already deployed. We want to connect it to the Ethernet port of the SCADA server. And as Johnny will explain shortly, a highly recommended solution is the use of Ethernet extended products over an existing single twisted pair. The last step of the solution is to insert a device server between the flow computer and the remote Ethernet extended device. Incremental step number two. Perhaps you want to install a flow computer and communications link to a derrick to be put online very soon. In this case, you can select the flow computer with the Ethernet interface. The installation of the communication link is very simple. Install a pair of Ethernet extenders over a single twisted pair, either pre-existing or newly installed, period. The migration can be done in stepping stone fashion. Since the industrial communication protocols have been extended for use over Ethernet, the learning curve for your operators is minimal. Here is a short list to keep in mind. You can continue using your legacy installations. Plus, you can also install more legacy requirements. You can use twisted pair already installed and simultaneously keep current with the technology trend. Don't worry about the twisted pair. It'll work. But select your barbed wire carefully. Let me hand this back to you, and thank you very much for your time, everyone. Katie, thank you.
You're welcome. I do have a couple questions that have popped in for Nathan, if you wouldn't mind answering them.
Yeah, of course. I'd be happy to.
The first one that popped in is, if the protocols are moving towards standard Ethernet rather than specialized non-standard Ethernet versions, why is the adoption of EtherCAT, Circos 3, and the like increasing from 2001 to 2015?
Yeah, actually that's really an excellent question, and I just briefly mentioned it in my presentation. Let me talk about EtherCAT. EtherCAT is, a really finely tuned real-time protocol, and there are going to be other applications that can only be best addressed when you are using a proprietary means. Even though in many instances this is decreasing, because if you recall that protocol stack, you look on the left, that there was the CIP motion. The CIP motion is also real-time. However, there's a slight difference between that and EtherCAT, and one of the differences is that EtherCAT has a stricter limit on the amount of jitter. So I know that's a little bit of technical detail here, but the gist of what I'm trying to say is that even though we can do more and more using non-deterministic Ethernet with properly designed application protocols, there still will be instances when we need to use something a little more proprietary. But I'm sure we're going to continue to see this evolve. Thank you.
All right, one more for you, Nathan. How much longer do you think these legacy technologies remain viable? And why not migrate to all Ethernet right now?
Well, my crystal ball is not going to give, a really clear answer. However, as Bert mentioned earlier, 75% of the industrial nodes are still legacy. They're not Ethernet. So there's a large migration path here that we need to follow. At the same time, because customers are still going to want to use these use these legacy technologies for some time to come, even though they'll still be forced eventually to go to Ethernet, the manufacturers will continue to manufacture them. So how long will that be? They're certainly going to be available in the short to medium term future, but in the end, I can't predict. On the other hand, the kind of dual question there in terms of, well, why don't we convert everything to Ethernet right now? I tell you what, that would really be great, and that's great for a number of reasons. One is that, as you saw in the presentation, take, for example, the Modbus protocol, originally designed to run over RS-485 legacy equipment, has been changed slightly. Not what it does, but how it gets it done by integrating it with Ethernet. So that is very easy. The learning curve, as I mentioned earlier, is short for the operators. However, if you want to go and throw all that legacy equipment, which seems to be operating, or actually I'm sure is operating just perfectly out, replace it with brand new equipment, pull out the old cable, install new cable, lots of labor there, meaning lots of cost, and you have the money in your pocket. I encourage you to do it, because then you're going to be there before everybody else. But the whole point is that most companies don't want to do it that way. They need to amortize their cost of migration over a period of time, and this can be easily done, actually, as Johnny's going to talk about.
If you don't mind me interrupting, Nathan.
Oh, please, Johnny.
In determining the length of availability for the serial devices, a whole lot of that is really due to, or is up to the chip suppliers. As Ethernet continues to grow, we'll see UART interface chips, line drivers, op-amps, things that are specific to the serial communication sector really disappear. I alluded to earlier, it's something that is a daily challenge on our end.
All right. Well, thank you so much, you guys. Nathan, thank you for your part of the presentation. And now, Johnny, it looks like we're heading back to you.
Hey, thanks, Katie. Nathan, thank you for the great overview, and especially including how Ethernet has been adapted for industrial use. While Ethernet has many advantages, affecting the migration from serial to Ethernet is not without a few physical layer challenges, both of which our copper link solutions address. First and foremost is Ethernet has distance limitations shorter than that of RS-422 and for RS-485, which is about 1,200 meters. Well, the distance limitation of the Ethernet is 328 feet and or 100 meters. Patton's copper link solutions blow away these distance limitations of Ethernet, and they are specifically designed for industrial environments, industrial wires, and industrial topology. We can push Ethernet up to 22,500 feet. That's nearly 4.5 miles. The second, which is no small task, is, and I believe Nathan talked about it a little bit earlier, is Ethernet is not able to operate on the same cable plant. Most other legacy communications equipment was operating over plain old telephony grade wire. Ethernet really requires Cat5 cable or greater to operate properly. A minimum of 2 pairs is required for standard Ethernet data, and 4 pair if you run PoE Ethernet. The cost of rewiring the cable plants and changing wire topologies is a big consideration to companies trying to make this migration. We get this every day. Our products operate over regular telephony-grade twisted pair and support data rates from 192K to well over 100 meg. The case studies and applications for our Ethernet extenders are, quite honestly, as broad as the number of devices with an Ethernet port. In the interest of time, I'm going to cover 2 case studies in which our CopperLink product line solved 2 different problems. This slide here is a prime example of how our CopperLink Ethernet extenders helped one of our customers reuse their existing infrastructure. This was a nuclear power facility in Limerick, Pennsylvania. Just happens to be my first up-close and personal installation. Their RS-232 equipment, which happened to be dosimeter meters, were installed into the reactor and had gone obsolete. The only option available to them was to buy replacement equipment with an Ethernet interface only. They estimated that to build new conduits and to run Cat5 cable, that is through a huge concrete barrier from the core to the network operations center, would cost them approximately $1 million. Our Ethernet extenders allow for connectivity over their already existing twisted pair that they were using for RS-232, saving that facility well over $900,000. They were able to make the switch over in just a few moments, preventing any downtime or suspension of network operations. I believe their total bill from us was just under $15,000. And quite honestly, today, it would be even less. Another interesting application we just recently completed was one that required the extension of Ethernet. Enbridge, a Canadian-based energy supplier, needed to capture time-lapse photography on their various construction site projects. The problem Enbridge ran into was really twofold. Their construction site was too far away from the PDC, or portable data center, for Ethernet connectivity, making an Ethernet-based PoE IP camera, or being able to use that Ethernet-based PoE camera, an issue. 2, the camera was to go outdoors and was a very harsh and drastically changing climate. This is not good for standard electronics. When Enbridge came to us for a solution, we used our custom environment enclosure along with a third-party extended temperature PoE power injector and our own extended temperature Ethernet extender to allow for Ethernet connectivity of over 1,000 feet. The PoE injector was used to both power the camera and its internal heater and fan. The environment enclosure to protect it from the elements. Onto the products. We have a wide range of CopperLink CPE, or the devices that will go out and connect to the various remote equipment you have. We have our controlled environment products, which are what we would call our standard desktop wall mount CPE. We have a ruggedized product line, which is used for light industrial environments. These have general mounts and convenient front-facing ports. Some of the products within this line support multi-drop topologies. This ruggedized or light industrial series is housed in a sturdy aluminum IP40 rated enclosure and supports operating temperatures of -40 to 85 Celsius. We can also offer the additional protection against condensed humidity through the use of conformal coating. For extreme or outdoor installations in the elements or subject to high amounts of dust or exposed to corrosive chemicals, where complete protection from harsh environments are secured against vandalism is required, we have our custom environment product line, similar to the one we introduced on the Enbridge application. We break our CopperLink product line really into 2 segments. We have our high-speed connectivity product line and our long-range Ethernet connectivity product line. Our high-speed Ethernet connectivity equipment allows for data rates of well over 100 meg. This equipment is most often used in applications not requiring long distance. In this product group, we support both point-to-point and star topologies. The bread and butter is our long-range Ethernet connectivity line. This here can support data rates ranging from 192 kilobits per second to 5.7 meg at distances from 4.5 miles to just under 2. For increased rate and reach, we can use special wire bonding technology or bring our repeaters into the network. This is something that separates us from the run-of-the-mill extenders. In this product line, we have solutions for point-to-point, star, and even multi-drop topology. I will not take time today to cover all the models, but I would love to talk to you on the phone or by email, and we encourage you to visit our website. From our website, you can easily order product and solution guides, which will give you a much more in-depth, detailed look into each one of our products. And of course, this is all free.
Thanks so much, Johnny. I'm just going to jump in here, and there were a couple questions that had come up while you were talking, so I'd like to get to those before we go to Sean. The first question here is, do these devices incorporate any form of line isolation?
Yes, all of our copper-linked Ethernet extenders incorporate transformer isolation.
All right, another one came in here. This one asks, what line coding methods are you using?
The beauty of Patton Electronics is we have many choices of modulation schemes to use on our Ethernet extenders. We really choose the modulation scheme based on the application. For our long-range product line, we use TC-PAM. For our short-range, high-speed, we've used various different technologies. The one in our latest high-speed Ethernet extender is using DMT.
All right, and I have one more question that we can answer right now. This attendee asks, what is the MTBF on these units?
The MTBF is not a static number. Each product has its own. I would be happy to send that answer to the individual or the individual who asked the question. The MTBF values for each one of our products can also be found on the product's web pages and data sheets. But if we get the contact number, I would be more than happy to send the MTBF information for our various products.
Well, Johnny, thank you so much for that part of your presentation. I'm sure we'll get to some more questions for you later. But now we're going to move on to Sean Garrity. Sean, go ahead.
Katie, thank you for the introduction. Once again, I'd like to thank everybody for participating in today's webinar. I don't know about the audience, but I know I've learned a lot, and I've worked with Patton for several years. As Bert Patton touched upon in his open statement, Patton is a diversified global micro-multinational manufacturer based in Gaithersburg, Maryland. These facilities support Patton's global partners to provide a single-channel system everywhere in the world by thinking globally while acting locally to provide a local Patton point of contact, local inventory availability, and local support resources. In other words, Patton seeks long-term channel and partner relationships with companies who are committed to the Patton product line, engaged with us in extensive training programs, cooperative sales, and marketing activities. So the image above represents from our home page where on the tab it says how to buy. And glossing over this image from our website, you'll be able to pick your country or region and see the appropriate Patton sales team. That sales team will help direct you to the appropriate channel and partner to address your requirements. So today, we put together a couple resources for the attendees. One, you can order a full glossy color booklet or download a PDF from Patton's website of our complete Ethernet extender product line overview. This will go over not only the products we covered today, but also various other models to address your unique distance and speed requirements. I also recommend that all the attendees download a copy of the nuclear power plant case study. I think this really provides some very unique information of what we can do in legacy environments, bringing in next generation technologies. Additionally, all the webinar attendees are also eligible for a free POE injector. All you need to do is contact your local Patton channel manager or regional director, who will give you the appropriate identification or source code number for the free item. They'll also put you in contact with someone that can help you fulfill the order. And last but not least, I have the esteemed duty after our webinar today of picking a lucky attendee that will be winning an iPad too. So you'll also be hearing from me in a follow-up. Hopefully you'll be the special attendee that will be winning this prize. If not, I'm sure I'll be following up with you to address any questions you have. Katie, once again, thank you for the time today, and I'm going to turn it over to you.
All right, Sean, we did have a couple questions that popped in for you, so I want to get to those since it's probably about what you just went over. The first one asks, how and where can someone purchase Patton extenders, and what is the expected turnaround time to take delivery?
Well, first we're going to start with selecting the appropriate region or Patton office, and from there they'll get a contact, and that contact will introduce them into a partner that addresses their vertical and market needs, and then we'll be housing inventory for fulfillment of the product.
So if you don't mind me chiming in, I just wanted to round out the answer to the question a little bit. Most of our Ethernet extenders are available anywhere in the world with a 48-hour delivery time.
We do have some more questions that have been coming in here as you've all been finishing up. Let's get to those right now. Johnny, this next question is for you. Can copper link extenders withstand outdoor installation, and what are the lower and upper limits on environmental temperatures?
All right, thank you. Yes, absolutely. The copper link Ethernet extenders can be installed outdoors. In fact, they can be installed nearly anywhere. That is really more so for the outdoor applications. We would use our Environet system more so. That's a custom product line, one that we can do to various different NEMA, IP, or even mil-spec standards. We're lean enough to do customized product according to the application. In terms of the upper limits and lower limits of our products, really right now we're more so at a minus 40 degrees Celsius for the lower limit and 85 degrees Fahrenheit for the upper limit of our products.
All right, thanks so much for that. The next question that's come in looks like it's for Bert. This attendee asks, about how many offices or locations do you operate?
Okay, offices and locations are different from subsidiaries. I would say we have about maybe 12 locations worldwide.
Nathan, I'm coming back to you for this one. This attendee asks, why not transition to wireless or fiber optic? Do I have to install new Cat5 cable in order to use Ethernet extenders?
No, you don't. Let me take your second question first. No, you don't need to install Cat5 cable for the Ethernet extenders. In fact, that's one of the major benefits. There's more than one, certainly, but major benefits is that you can use whatever twisted pair is already installed. In terms of using wireless and fiber, fiber is certainly much more expensive. Wireless has problems with security. It also has EMI issues, which is another way of saying you can have interference from other electromagnetic sources, and so your bandwidth can vary. And in applications that are delivering a lot of data or data that has to be rapid and cannot tolerate a retransmission time, wireless is a problem.
All right, we have time for this one last question, and Johnny, it is for you. This attendee asks, do I need crossover or straight-through Ethernet cables when connecting to my remote device?
Just a simple answer is yes, and you can use either, to be honest, either the crossover or the straight-through. All of our Ethernet extenders are MDIX auto sensing, so they're going to sense what your cable is, sense what the devices we're connecting to, and really configure itself. That's one of the beauties of the CopperLink product line. Plug and play.
All right, guys, we're going to have to wrap up the webinar right there. I want to thank Bert Patton and Nathan Meyer. Johnny Grant, and Sean Garrity for sharing your expertise with all of us today. Thank you so much, guys.
Thank you.
Thank you. You're welcome.
And a thank you to all of our audience members for being part of this webinar event. To find more information, please access the Resource widget to download free white papers, case studies, and our Ethernet Extender product guide. And as always, feel free to call or email us with any questions. Our contact information is on your screen right now. You will be receiving an email from GlobalSpec with a link to the on-demand version of this presentation, a PDF of this PowerPoint, and a frequently asked question document with a Q&A transcript. I want to thank you again for taking the time to learn more about Patton solutions for migration to Ethernet IP. Take care, everyone, and we'll talk to you soon.